Hi, welcome back to Praveen Tech Lab. In episode 1 of MCP series, we covered the basics of MCP, what it is, why it exists, how the architecture works, and we built our first Hello World server. Before we dive into today's main topic, first we need to understand Python Asyncio, a key concept for building real-world AI systems that handle multiple operations at the same time. Next, we will take a step further and explore MCP capabilities, also known as building blocks of MCP. They are tools, resources, and prompts. We will do a hands on deep dive into each of these and understand them with real code examples. Let's get started. Python Asyncio. Asyncio is a Python library used for asynchronous programming using a single thread. It allows to run multiple tasks concurrently, not parallel, using an event loop. Instead of waiting for a task come, like API call or DB query, the program switches to another task. Let's understand how program handle multiple tasks over time in sequential versus concurrent programming. In sequential execution, tasks are handled one at a time. The system completes one task fully before moving to the next task. If you look at the timeline, task A run first, task B, task C are in waiting state. Once task A completes, task B starts, and finally task C runs. But while in concurrent programming, task A starts first and while waiting for some input output operations, program switch to task B. While executing switch B, if response comes for the task A, program resumes the task A and completes the task A. Same way for task C. This is called concurrent programming. This makes it very efficient for input output operations. We will understand this with using a restaurant waiter analogy. A waiter takes one order, then goes to the kitchen and waits there until order ready. Meanwhile, other customers are waiting. Some are getting frustrated. This is a blocking behavior, right? Now imagine a smarter waiter takes order one, sends order one info to kitchen. He doesn't wait. Immediately goes to take next orders. When order one is ready, he serves it instantly. Same thing happened with Asyncio. Instead of waiting for a task response to come, thread will pass task one and executes the task two. We'll try to understand this with code. Now we are going to understand the difference between sequential execution and concurrent execution with code. Here we have two versions of almost the same program. Look into our first version. We have defined a waiter underscore take order function. This function takes the order as input. Inside this function, we are printing taking the order as output. Next, we are simulating the kitchen processing with a time sleep of 7 seconds. After this time delay of 7 seconds, we are printing order is ready. Next, we are returning the server served the order message. Now look into main. We are calling this waiter underscore take order function two times. First time we are calling with order one as input. Second time we are calling the order two as input. Now we execute the code and observe the what's happening here. When you look into the output, the waiter take order function is executing sequentially, while order one is processing, order two is in waiting state. Order two is started executing only after finishing the order one. It's pure example of sequential execution. Note down to complete this both orders, it took total 14 seconds time. Now look into the another version of the code with async IO. Waiter take order function we are defining with async def. Now this function becomes a coroutine. A coroutine is a special kind of function that can pass itself and follow the other task to run. Now notice this line, await Asyncio dot sleep 7. This is very different from time dot sleep 7. Asyncio sleep of 7 is a non-blocking. That means this task says I need to wait 7 seconds. So while I'm waiting, let's some other task to run. This core idea of concurrency. Now look into main. We are calling waiter underscore take order with order 1 and order 2 using the async IO gather. Gather schedules multiple coroutines to run concurrently. So instead of doing order 1 and then order 2, Python starts in both functions at the same time. Now we'll execute this and see. Both tasks reach await async IO dot sleep 7. Both pass. While one is waiting, the other can also progress. Now both completed. Now observe the how much time it takes to complete the both orders. It took only 7 seconds. In the first version, the code takes 14 seconds to complete because the tasks are executed sequentially. In the second version, it takes only 7 seconds. Since the tasks are handled concurrently, this shows that async IO improves the efficiency of our program. Now we will move to our main topic for today, MCP primitives or MCP building blocks, tools, resources and prompts. Using tools, resources and prompts, we can define the functionality of an MCP server. In other words, the features it supports. That's why these are considered the core capabilities or building blocks of MCP. Tools. Tools are used when AI wants to perform some actions. These actions may be read, write, send, execute. Examples are get weather data, query a database, fetch room info, send an email. Next, resources. Resources are read-only sources. Resources are used when AI wants to fetch some information. Info may be inspect, read, lookup. Examples are read file metadata, get log info, get system information. Next, prompts. Prompts are predefined templates. Prompts helps AI understand how to respond or behave. Examples summarize the document, generate a report in this format, answer like a support agent. I'm going to show a simple and practical MCP demo. Using this, we can understand these MCP capabilities. To make this easy and fun to follow, I will be using a movie night demo. This demo exposes a movie recommendation engine through MCP. The client will able to search for movies, get snack suggestion, access the full catalog, and get structured prompt for movie planning. Without delay, we jump into code. Create the project directory. Change to the directory. I'm creating the virtual environment. Now activate this. Now install the MCP package. Now open this our project directory. Now we'll create our movie night server code. Now I'm importing few modules in JSON and sys. Next, I'm adding the Windows fix. If you are running on Windows 32, you need to add this. Now I'm importing our fast MCP module. This fast MCP is a high-level SDK wrapper from Anthropic. It handles JSON RPC communication and also it supports MCP server functionalities. Name our server instance movie night demo. This is how our MCP clients identify the server while connecting to it. Now we define our movie catalog data sets. It is a static movie catalog contain movie dictionaries with metadata ID, unique identifier, title, movie name, genre, what type of movie it is, science fiction or animation, duration means how long the movie duration is, family friendly, it is suggestible to watch with kids or not, rating out of 5, what is the rating of this movie, available. Available true means it is available to watch. False means it is not available to watch. Next, define our first MCP tool, find movies. It helps the MCP client to search movies in the movies catalog dataset by title or genre. It also accepts a family mode argument. If you turn on this family mode, it adds one more layer of filtering on the movie's suggestion. Finally, we are formatting the data and sending the structured data to the client. Next, we'll add one more tool. It is a suggest snack tool. It suggests the snack ideas based on the movie title or movie vibe. If movie name is Inception, it suggests the layered brownies because the movie has a layer inside layers like this. It will suggest the snack ideas. Next, we will define our first resource. Now we defined our first resource, movie catalog. This MCP resource provides the complete movie catalog as a structured JSON data. It includes total movies, currently available movies, and full movie details. This URI defines readable data endpoint that the AI can access to fetch this catalog. Family movies. This MCP resource returns only family-friendly movies from the catalog. It filters the movie list based on the family friendly flag. Clients can reach to this resource using this movies colon family resource URI. Now we'll define our first prompt. This MCP prompt defines how AI should generate a movie night recommendation. It takes user mode and duration and provides clear instructions on how to pick up movies and suggest snacks. It ensures AI gives a structured, relevant, and personalized responses. We are registering our prompt with mcp.prompt. Now we'll run our MCP server. Now our MCP server code is ready. The server code now has the movies data catalog. All these our MCP capabilities are using to expose the data to client. First, we defined one find movies tool. With this help of this tool, clients can search the movies. Next, suggest snack tool. Using this tool, clients can get the snack ideas. Next, movie catalog. To get the movie catalog using this resource URI. Next, get family friendly movies list using this resource URI. Finally, we defined prompt, complete this prompt that AI can use. Next, we are going to build the MCP client code to verify the communication between the MCP server and the client. I have already written the MCP client code and I explain it using a code flow diagram for better understanding. While building the MCP client, the first step is to establish the handshake between the client and the server. The handshake happens in multiple steps. First, we need to spawn the server process. Next, initialize the communication. After initialize the communication, connection will be established with server. Now, same this process will look into the code. Spawning the server process happen with this async IO stdio client with server parameters. Look into the server parameters. Here we are defining how to launch our movie night server. Why we are launching the movie night server in the MCP client code? Because our transport type is a stdio. In stdio transport type, client is the responsible to launch the MCP server. Here our MCP server will be launched as a child process. During this line, our MCP server will be launched and it creates the stdio pipes, stdio in and stdio out. Next, initialization process. This initialization process happen with these three lines of code. First, we are creating the client session. Next, we are doing the handshake with the server using the session.initialize. Now we'll check this and see communication is successfully happened or not. I mean, connection successfully established or not. Yes, connection established successfully. Next is we are going to work with the tools. So I'm enabling the demo tools function. Look into the code flow diagram. Now first step is we have to discover the tools. Once we discover the tools, we can call those tools to get the data from the MCP server. First, we will look into the code how we are discovering the tools. Demo tools function. Session.list tools. It will provide the tools available on the MCP server. I'm calling session.list tool. I'm printing this. Now we'll execute this code and see. Yes. Now we got the tools available on the MCP server. One is find movies, another one is suggest snack. Next step is call the tools, right? First we'll call the find movies. We can call the tools using the session.callTool API. This one. I'm enabling this. Now look into the code. Session.callTool. I'm passing the find movies tool name and passing arguments as a query science fiction movies and family mode enabled. So I need the movies list related to science fiction and family. I can watch with kids. Now we'll run this code and see. Yes, I got the one movie matching to my interest. That is Martian. It is a science fiction movie and I can watch with family. And it is status also available. Next, we'll see snack suggestion for this tool. Here I am calling the session.call tool with suggest snack tool name and providing the movie name as Inception. For I want the snack idea for this movie. Yeah. Now you can see layered brownies because the movie has layers inside layers. This is the snack suggestion I got for the Inception movie. Now we understand how to list the tools and how to get how to call the tools, right? Now we'll see how to read the resources. For that, we can use list resources to get the list of resources available on the MCP server. First, go to main function, comment out the tools, enable the demo resources function. Now look into the resources function. I'm calling list resources API. It will list the resources available on our MCP server. Now we'll execute and see what are the resources available and yes, available resources are movie catalog, movies, family. These two are the resources available. Now we'll see next how to call these resources. I mean, resources are read-only sources, right? We can fetch the information only. Here I'm calling the resource catalog resource using the read resource. We'll execute this code. Let's see. Movies catalog resource. It provided the information movie night demo catalog. Now we got the data from the catalog resource. The data is catalog name is movie night demo catalog. Total movies are five. In that five, four are available. This information we got from the catalog resource. We have family catalog, right? It will provide the list of family movies. Now we'll execute and see what are the movies family oriented. Family movies are Inside Out, Martian, Coco. Total 3 movies. Now we understood how to get the list of tools, how to call them, resources, how how to get the list of resources, how to call them. This we understood. Now we'll look into the prompt. Comment out the resources. Enable the prompt. For to get the prompts, we can use the list prompts API. Session.list prompts. If you call this, it will provide the prompts available on the MCP server. I got the response. Available prompts in movie night prompt. Prompt template for asking to AI to recommend a movie night plan. This is the prompt template available on the MCP server. Now we will get this prompt from MCP server. For, for that, we have to call using the get underscore prompt. And sim. Yes. Now we got the response. Generated prompt is you are a helpful movie night planner, user mode fun family. Because while calling this we passed in mode as fun family science fiction and maximum duration 150. These parameters we passed, right? The prompt is generated with this data. User mode fun family science fiction, maximum duration 150 minutes. That's it for this video. In this episode, we covered the fundamentals of synchronous versus asynchronous programming using Asyncio, and then we moved on to the core MCP capabilities, tools, resources, and prompts, along with a hands-on demo. You can find the complete code used in this demo on my GitHub. Link available in the description below. In the upcoming videos, we will go deeper into HTTP transport mode and building production-ready AI agents. If you found this video helpful, please consider subscribing to the channel. And if you have any questions, feel free to post them in the comments below. Thanks for watching, and I will see you in the next video.